This video is going to go over setting up the balance code and going over the remote app. First, we want to test the hardware and make sure everything is functioning properly. So we can go to add-ons, manage add-ons, and go to the folder where the library is installed. And in there, the first thing we'll do is just run the demo code to make sure the hardware works okay. So this is a MinSeg Mega, so we'll open this, plug the device in. We can look at the device manager to see what COM port it is. This is COM port 3 for the Arduino Mega. Since it recognizes it as a Mega, we won't need to specify it. If we wanted to specify it, we could go to Hardware Settings, Hardware Implementation, Target Hardware Resources, Host Board Connection. In this case, it's set to automatically, which is fine because it recognized it as an Arduino Mega. If not, we could set this manually and then specify the COM port. Now that this is set up, we just press the Monitor and Tune button, wait for the code to compile and run on the system, verify that all the sensors and actuators in the system work. After the code connects, it starts running the code. We can observe that it's reading the gyroscope and the accelerometer. As we move it, we can verify that both of the motors are spinning and both of the encoders are being read. We can also verify that the magnetometer is working, and we can turn the potentiometer to verify the potentiometer is working. Now that we've verified the hardware, we can stop the system and close all this down because we know all of our hardware is working. Next, we want to run the balance code. Balance load is also located in where the library is installed. It is in the balance app. If you have a system you'd like to see this available for, just let me know. Here we just open up the balance code. And here we want to first go over what this code is doing. This code is running a full state feedback controller. There's 4 gains. There's 4 different states. Alpha and alpha dot are the angle of the pendulum, and theta dot is the rotation of the wheels. All the state estimation is done. This way the user just focuses on tuning these gains and getting the balance code running. First thing that we want to do is we can interact with it over Bluetooth, tune and plot at the same time. We don't want to do this now. For now, we'll just run the basic code, which will be reading the gains, uncomment this, and this way it's going to get the controller gains and download them right to the device and run them. Once we've uncommented this, we just want to run this on the hardware. You can run this in external mode. First, we also want to notice that when the code is loaded, it runs the sample time. In this case, it's running 7 milliseconds. This loads automatically when the file is loaded. And here we want to run this code. We just push the Monitor and Tune button. Once the code is downloaded to the device, the first thing we'll need to do, well, there's 2 things we typically will need to do. One is to figure out the gyro bias. In this case, the state estimation will do that automatically in the first half a second once the code starts. It will automatically calculate the gyro bias. It's important that the device isn't moving when it calculates or first runs the code when it's calculating that bias. The next thing we're going to want to do is figure out what the perfect angle for balancing is. And if we don't have that perfect angle where this just barely balances, we can adjust what that angle is here. So once it connects, which it just did, I can see that the balance code is running on the device, in this case, not very well. And the first thing we'll want to do, and the reason it's running slowly actually is because it's just using USB power. This is set up to use the 7.8 volts. So it's scaling it, assuming that there's 7.8 volts available. Right now, the switch on the system is set up to where it's not using the battery. So I'll flip this down so it does use the battery. And then you'll notice that it's able to balance much better on its own. This is running in external mode. That means I can view this graph. And you can see that the system is balancing. This is alpha. It's balancing around 0. If it wasn't balancing around 0, I would want to adjust this angle so that it actually keeps it at the perfect balance point, which would be 0. If this angle's off a little bit, it'll have a tendency to wander away because it has to try and balance it at a non-zero angle. So we can see that this angle is pretty good. It's balancing. I'm connected and reading the values, and I can edit these gains while it's running. So I might try increasing this proportional gain on this term and seeing what the effect on the system is. In this case, making the proportional gain makes it a little more jittery. And of course, I could lower this gain. Part of one of the labs you would do is figuring out and trying to tune these gains using different tuning procedures. Now you can see it's just a little slower. So this is how you can interact with the system, tune the gains manually, and all of this information is being sent over the USB cable. The USB cable is serial 0 on the Arduino. So even though our COM port of the device is COM port 3, the Arduino, it's sending that data over the USB cable, and the USB cable is serial 0. That's the basic setup. Next, we'll go over running this setup using the serial tune and plot. Using monitor and tune is limited to the bandwidth, that the number of signals you can log and how fast it can log it. In this case, it has enough bandwidth to read enough signals and modify these values as it's running. If we wanted to do this over Bluetooth, we wouldn't be able to use monitor and tune. The next step is to just try to use and send data serially. So we're going to comment this out. And this will allow us to go over how this block works, which is going to send data back and forth through the serial port without using monitor and tune. And this is going to help us understand this block so we can use Bluetooth communication and remotely control it with the app later. We're going to uncomment this and then discuss this block. This is going to be sending, in this case it's sending two signals, theta or alpha, the pendulum angle and the wheel angle, alpha and theta, and it's going to be sending it to our computer. It's going to be taking information from the computer. It's going to be sending it through the serial port, in this case the 4 gains. And for the remote app, it will be using a signal for the device to go forward and backward, magnitude and direction, and a signal to make it turn left and right, magnitude and direction. To set this block up, the information that you have to set up first is what serial port you're sending the information through. Since we're using the USB cable, that's always Arduino serial 0. Serial 0 on the Arduino is connected to the USB cable. Next is the COM port that is the USB cable, or connected to serial 0 on my computer, and the USB port is connected, or that USB cable is COM 3, that's connected to the Arduino. So I set this up as COM port 3. This then will, when you download this code, it'll set the Arduino up so that it sends data through serial 0, which is the USB cable. Next is there's 6 variables we're going to be getting from the computer while it's running through the USB cable. And these are the initial values of those 6 variables. So these are the 4 controller gains, and forward, backward, left, and right. Those are going to be used for the remote app, and we're not going to be using those to tune anything. It's important that you put values here because it has to know what values to use for these gains initially. and that gets downloaded to the device and it's always on there. Once you connect to the device, then you can change those values by connecting to the COM port and then sending the data. And then if you want to plot, we have two variables we're plotting. We're going to plot 500 samples, and then you can click once you're connected to plot. So once we have this set up with the initial conditions and the right serial port, then we want to download this. We're not going to use monitor and tune. We're just going to deploy this to the device. This will compile the code. And after it's downloaded, this will always be running on the device. Even if it's disconnected, even if you reset the power, every time it's going to get power because it's deployed, it doesn't need to connect. It's going to run this code anytime it has power. Here we can monitor the build process. We can see how much memory it's using. We can see that it's built and it has been deployed to the model. Once it's deployed, and then because the code's always running on it, I can turn this up. You see it starts to try to balance. I can hold the reset button. When I let go of the reset button, give it a second to calibrate, and then it will begin running the code and balancing. Once it's balancing, now I can connect to the device. Whenever you're using COM port 0 and it connects, unfortunately it will reset the board, so you will have to hold this initially when you connect, just because that's the way the Arduino is set up. When we're using Bluetooth, we'll use a different port, and then you can connect while it's running. So here we're going to connect to COM port 3, and we'll be able to view some of this information in the command window. So we'll get that in a place we can see it a little easier. So we're going to connect to the device. You can see that the lights just flashed. It reset the device. I was holding it, so now I can let go. And it is now connected to the device. You can see the green light means it's sending the data. So if I wanted to, I could click to plot some of the data. And it shows me the two angles as it's running. I could click stop. If I read in here, it indicates where the data is stored. It's stored in the variable fdat. It's stored in a file, fdat, and then I can type plot fdat to plot all the data that I just stored. So that's after you're connected, that's how you can plot the data. Next is tuning while this is running. Since it's connected, then I can change these values again to change the gains. So I might try a really high gain here. And then I can click send to the device. Oh, it multiplied it by 0. So that didn't work. I didn't see that that was in there. Now it's sending 0. Now I can get rid of this and then send it to gains again, and it does start to balance again. Now with a much higher gain. I tried a much lower gain. And again, you could go through an exercise of trying to figure out how to tune the gains. So now the gain's too low, and then it fell over. This walked through the basic setup of how to connect using the serial connect, plot, and tune block. You can also see that as it's connected, it will show up and indicate that it is connected on here. So here it's running again. I'm going to change this gain back to a good value so it starts balancing. And of course you can disconnect, but then because it's on serial port 0, it will turn the device off. If we wanted to again run this, because the code's always running, you can start it back up. So we're going to reset it, connect, and then once it's connected, then we can again plot the data or tune it. Once we stop, it'll store the data. And this is the basic overview for using this block.